This is the second part of tutorial of Siemens NX manufacturing specified to lathe or turning. And in this video, we're going to go through the step by step by defining the operations in the main steps. In the previous video, we have gone through defining different steps in setup section, and now we are focusing in the main program. The main program of your part is basically the sequence of a different operations that needs to bring up one by one after each other, depending on your decision prior to defining your main program. In a sense, you need to first decide what is your shape of your part, how does your part look like, where it will be clamped, what are the tools need to be selected, what are the parameters to be selected, and what are the sequence of the operation of manufacturing that you're gonna have. For example, in this specific part, we're gonna have first facing a part. So we need to decide about the parameters, depth of cut and parameter settings here. Then we're gonna have a spot drill to help us center the drill. After that, then we're gonna have a drill. It might be several drill depending on the diameter. Then we're gonna have a rough outside diameter, following by the groove of outside diameter, finishing outside diameter, roughing, bore inside diameter, finishing inside diameter, followed by groove, finishing bore of remaining internal diameter, and then thread cutting if it is inside or outside. In our case, it's actually outside, but this is the another tutorial that it was supposed to be inside thread, and cut off the parts. I'm not sure if we're gonna go through all the processes and all the operations here, but at least this is an examples, and the video shows that how it is finally it's supposed to be, and at the end we might actually use the cutoff part to cut the part from the spindle itself. So the message here is that you need to know beforehand what are the sequence of your process that you need to decide about it as a manufacturing engineer, which of them needs to come first, and what are the suitable process parameters and tools for that. So after having prepared of those steps, we're gonna go through step by step of this operation. Let's see if we're gonna go through the whole operations or we're gonna stop at some point. But now I will start one by one. Again, similarly with the similar approach, I will first present you the slides, and after that I will move to software to concretely apply those ones and see that the possible errors or problems, and see that how we can possibly interact with the software to solve the problem. All right. The first one is perhaps, for example, the facing. So in the facing operation, we need to use a correct tool. So it's the outside diameter tools that we're gonna use. Again, here we can decide about it. Do we need to do the facing roughing first and then finishing, or are we considering that the last pass of our operation is already in the finishing stage? If it is two-stage, then obviously we need to define two different operations, one for finishing and after that roughing first and after that for finishing. So of course the parameter settings are different depending on the roughing state or finishing. But in this specific case, we're gonna use only one operation, which is the finish, and we're gonna finish the part first. So the important thing is that the geometry needs to be used as avoidance. So here it refers to the part itself, and then the method is of course lathe finish. Tool is outside diameter tool, and then the rest of it here is to generate the tool and then define the trim plane. I will show you where does the error comes and why do we need to define a correct trim plane, because in some of the cases, depending on the orientation of the part, we don't need to define the trim plane. So that's why it's not necessarily a defined stage that we necessarily need that. After that, we try to generate the path, and we verify the path. We go to the second operation, which is the spot drill. For the spot drill, in the previous video, we have actually created the spot drill. So the tool is already existing in our software. And now we just need to create a center drill spot drill as a method, as a lathe center line. The spot drill will be used as our tool, and then similarly to previous one, the geometry is avoidance. Here is simple. Normally there wouldn't be any problem or something, but we will figure it out. So we're gonna have first a spot drill followed by a drill. To define a drilling operation is basically the same, except that now, if you remember, we have not yet defined our drill. And here from our geometry that we have for this tutorial, the final diameter of the hole that we need to make it a drill hole, it's actually 20 millimeter by diameter, if I'm not mistaken. So in that case, we can consider that, for example, it can go with the one single pass of a final diameter of 20, but it's not really easy to say so. It really depends on the specification of the parts and the material quality and also the tools that we are using. It might be possible that sometimes we need to use first another drill to make it a little bit the hole there. So for example, we can go from a spot drill to a drill number 10 by diameter, so 10 millimeter in diameter, and then move to 20 if the material is hard or our tool is weak or if we don't have any lubricant or something like that. If not, in this case, we can go straight to the 20 millimeter. And of course, another thing that we need to consider is that do we need, based on the surface roughness specification of our drawing, do we reach the final surface but by only drilling, or do we need to leave a little bit of material to do the finishing in the drill hole area? In a sense, if there wouldn't be any specifications or the roughness is rough enough, the surface intended is rough enough, then we can perhaps go with the only drilling as we are doing it here with only drill with a diameter of 20. We're going to finish it all. If not, for example, we could use a drill diameter of, for example, 15 and 16 and then leave like 4 millimeters, 3 millimeters to have two pass of the finishing to reach the intended surface roughness. As you know, you can reach a better surface roughness by just internal cutting tool with the specified parameters that you can figure it out from the process parameters that you extract from the tool catalog, and depending on the material, of course, you can reach a better surface roughness compared to when you are only drilling. But in this case, as I said, we are only going to drill. Another thing that we need to pay attention in the drilling is that what is the depth of the drilling and what is our depth reference. In this case, we're going to use the tool shoulder, and we can see that how much the tool has moved on, so then we can make sure that we are making this hole throughout the whole part and not cutting it out. So I will now switch to the software. We'll define these three operations, and then I will pause again and go to another section. So now I will open the software now. So here is where we have left last time. So here now I can go and define first facing. So I have the list of creating operations here. When I click the list of operations, now I have the list of operation appearing here. So first one is a spot drill, the drill itself, facing, and so on. I can also take a look beforehand to our list of tools. So here you can see that we have one tool outside diameter, the second one is spot drill that we have already created, and then the number 3 is the another outside diameter that one of them we can use for our surface area. All right, so now I will define the operation. So for those ones, you can just bring the mouse cursor here and then see that which of these operations are we now interested. If you don't remember the icons, there wouldn't be any problem. So you just need to wait on each one and then read through and see that which one is your preferred operation. So for now is our facing. So this is the one we are going to do the facing. On the same program, 1, 2, 3, for example, now we need to choose the tool. So for example, I choose this 51. The vocabulary that we need to use for the geometry is the avoidance. So simple, most of the operations are defined in the avoidance, and in avoidance, it basically means the tool part, the part component. But then we have the containment. The containment is the one that there is a risk of colliding with the spindle. Otherwise, most of them are avoidance, but it's anyway better to pay attention because this is the source of a lot of errors and mistakes of students. Then you can double check that one to make sure that you are defining the operation correctly. After that, we are defining a lathe. So here is the same stuff that I was telling you. If you want to leave some amount of material for the finishing, you can define roughing now, put more material removal for the roughing so that you gain some time. If not, you can already do the finishing. It really depends on how much material you have left here. So this is something that I was able to define it, but sometimes it's out of my control. For some stuff, the stocks are cut in an inclined way or something like that. So this is out of our control, or the shaft is too big, and then we need to gain some time. So we need to do first roughing and then finishing. But in this specific case, it's only, I guess, if I'm not mistaken, yes, 3 mm material to be removed there. Diameter is so small, so I'm going to do right away the finishing. In case of you have some different operation for finishing, you can just make an underscore and I don't know, calling rough 1, rough 2, finishing or something. But in this case, I'm going to have only facing. The better you are renaming your operation, the easier it is for you to following it out later. And also for anyone working on your program or for operator to figure out what you have actually intend to do. So now this is facing, I'm going to have one facing only. Click OK. Then after that, I have the menu. Let's do something. Before we do anything, let's create to do the auto generate. To just see that without to do any changes, is the geometry that is showing the material removal, it's something that I'm looking for, or there is an error that I need to figure out how to solve it. If I now create the error, to generate the toolpath, I can see that it's already in a wrong direction. I just wanted to do the facing. But maybe this view is not very clear. So we go to the verify mode, and then I can see that the toolpath, how does that work? Pay attention, and you can see that the tool starts from this point. It goes and engage with the part, and then after that it's finished. It is this tool, this is this line, and then first comes axially out of the component and then radially up. So this is the first point and confirmation of the point that we have defined in the previous video. To do that, for example, I can click the 2D material removal, and then here is the animation speed. Sometimes 10 is too fast and 1 is too slow. Let's see, for example, what would be the 8 if I would be able to follow. And you can see that this is facing, but these are all something that I'm not really interested in, or it might be work for some cases, but in this case, I only wanted to have the facing. So in a sense, this is not what I'm looking for, and this is clearly an error. So I will stop the animation and see that how can I find the problem. So the problem comes from the cut region, right? So it means that I don't have enough limitation on the cut region maybe. So I will go to the cut region. I have the range here or edit. I can see, for example, what is it now? Currently, if I click display, I can see that this is the whole area that it is currently under my cut region. I will cut the region. And then, for example, let's try this axial trim plane 1. I click, for example, point, and I will select here, and you can see that it got the membranes here. And now I can see that it probably works fine. Let's try it out. Again, generate, it's always first generate, then verify. The toolpath is now generated, and then I can verify that one. It looks okay, but let's figure it out. I can again click this one so that I can see that actual material removal. Now it works fine. There is no collision, no wrong tool pass. So this is fine. The next thing that I need to do is to figuring out what are the machining process parameters that I'm interested in. There are a bunch of other sections and different scenarios that it can be possible to figure it out. So I kindly invite you to figure out or take a look to those ones and then see that, okay, if there is something, okay, I cannot do anything here, or there are some different orientation that I might be interested or something like that, or there are zigzag. And so I kindly invite you to a little bit take a moment, then familiarize yourself with the software and see that what kind of options is available and where to find them. So one of the things that I find it here is that I can see that now I have the depth of cut of a variable, average variable, for example. So we have the variable here, then I have the maximum depth of cut of what, let me first see this one. So you can see that there is two cutting path because the material that is here is on these two settings, right? What will happen if I put one and I put it, for example, already it affected. So you can see that now it is 4 cutting path. What will happen if I put the constant? Now I have the 2 1. So this is the, for example, this one. And now I can see that how does that generates for me. So now I will have more cutting paths. I have very less depth of cut, and it takes 4 times. Maybe it's good, maybe it's not. It really depends on your cutting scenarios. What are you deciding based on the drawing and specification of your component. So for this one, for example, let's see what will happen if I put it constant and I put it, let's say maximum of 1 millimeter. Now I have 3. It makes sense because I had 3 millimeters of material to remove, and I'm saying that take depth of cut of 1 millimeter each time. So this is something that you might also need when you are doing your assignment, since I might have defined sometimes the limitation of a depth of cut, or in real life, this is something that you are deciding based on the specification of your drawings, the material you are machining, and also the tool that you are using, and specifically the catalogs, what the catalog is actually providing you when you are doing the calculation. After that, then I have the feed and speeds. So this is also something else that is important. So feed and speed. So here I can see that the feed rates. So here I can have millimeter per revolutions, and then basically there is also spindle speed here. So for example, I can have it based on RPM. I can have, let's say, well, this is now something that I put it, let's say, randomly here for the sake of this video. But of course, you know how to calculate the parameters of a spindle and then the feed rates and so on. So now I'm putting this one as a value. And then you can basically see that what are the other options. Of course, there are some of these, we will see it later on. But as I said, you can just check it out here. Then there are different type of a thing like linear zigzag, I don't know, contour zigzag. So you can see that there are a little bit of changing in the different settings. So I will first, again, generate, verify. I don't need to necessarily do this 2D material removal. I can just click it like that. 1, 2, and 3 pass. It goes to the home. Again, I can check that there is no collision. Everything is fine. So now our facing operation is done. When I click OK, I need to still click here OK. And to double check that everything is fine, I go here to the list of operations and I can see that I have the facing, the path is okay, and everything seems to be fine. And if I expand these ones, then I can see that based on the parameter settings that I do, I can see that I have 365 millimeters of the length of the movement of the tool, in which including 194 millimeter of cutting, 171 millimeter of non-cutting materials. So these are all important when you are counting for the time that is finally defining the price, the cost of your manufacturing. With the parameter settings that I did, it estimates that it takes 23 seconds for doing this cut. All right, so this is this operations, and then we go to the next operation, which was the spot drill. As you remember, you can see that we have already the spot drill defined in this section. So then what we need to do is just to create a new operation. We go create a new operation, spot drill, center line, into the same program. Spot drill is correctly selected. Again, we are going to work on the part itself, so avoidance. And then here we're going to select the lathe center line. Once we are selecting this one, we are good to go. We click OK. Similarly to what we have done before, I'm going to generate this one to see that if there is any mistakes or not. I'm going to take a look here. Maybe just better to take a look at this point. There will be a center line. It should be all right, but then we can still check what are the other parameters here. So you know that the spot drill, it should be of very high spindle speed. So for example, I go to here again, spindle speed, selected spindle speed per RPM. For example, I can put, I don't know, let's say 900, for example, or 1000, and this is fine. Then I have the other parameters, for example, where are the cut and so on. So I don't engage with this one now. And then let's see if I have some other things. Yeah, so there is a depth of reference. So I want that from the tool dip to tool tip, so the tip of my spot drill, that it goes inside the part 3 millimeter, for example. But of course, again, it depends on what is the size and what is the exact spot drill that we are moving. So generate and verify. Just double check there wouldn't be any collision, there wouldn't be any wrong movement. So this is all right and everything is fine. So I click OK and OK. So now again, spot drill came here and then the spot drill we had, and it's associated with the center drill that we have here. We can also check it out from the operation or machining method view span. All right, I go to the next operation, and this is the drill. I go to the drill. So as we confirmed and we agreed, we're gonna do only one drill and only one diameter of 20. But as you remember, we have not defined the drill yet. So I go here to the list of my tools. I can see that there is no drill, and then station number 4 is open. So now we'll define, create a tool. I have a drill here. I can have a bunch of other tools. For example, I can have the groove, internal, outside diameter, and so on. But now I will define the drill. You can also retrieve it from library, for example. Then here again, it's better to call the tools correctly. For example, I can say diameter 20 millimeter, and then might be that there would be a different length. So I can just quickly specify here so that it is easier to find it out. Don't forget to define it here. Now let's define it wrong first. Like if I put the generic machine, you can see that it comes here after our turret name. So this is something that I don't want to use it now. So I will just delete this one and recreate the tool again. This time doing it correctly. Now this is the D20 drill, and now I will dedicate station number 4 to our drilling. I click OK, and then diameter 20. Then the rest of these parameters, as you can see, it got updated based on the standards that is already recognized. But if they are not correct, this is based on us to define the correct shank. You can see that what are the geometry of the shanks. You can easily see what are the catalogs of the shanks and tools that you are using. And it is important that you define it exactly to those ones. If you want to make sure that there wouldn't be any collision or any accident or problematic operation in your operation list, so you need to define all those parameters correctly. But if you are operating something very simple like this one, we are sure that it's perhaps not gonna collide, so that the length of the drill is longer than the whole part. So then there wouldn't be any problem not to define these ones. So these are just to see that if there would be any collision or not. But for now, I will now select this 20, this 118, it looks okay, but anyway, you can check it out. As you can see that 150 is the length of my drill, but however, the length of my part, it was about 155. So if I put 150 in with the considering that there would be after that the shank and that kind of a thing, so there would be a collision anyway. So let's say that I have another drill that I have, and it was, for example, tailored or something like that. I put it longer here so that there wouldn't be any problem. And then there would be anyway two flutes and that kind of a things. All right. So I click this. Now I have my drill. Next, I will create a similar operation than the spot drill, but this time with the drilling one, same program. The drill is selected correctly. Again, the same vocabulary need to be used here, avoidance, and same method of cutting. Center drilling, I have only one drill, so I don't need to rename this perhaps. So I can just leave it as it is. Similar to same operation, I will first generate automatically and then verify to see that where does that goes. I can see that it's not enough. It doesn't go or penetrate to the part at all. So now I know what I'm looking for. I'm looking for a distance. So here I can see that the starting point and depth. From the starting point and depth, I can define it based on the tool tip or based on the tool shoulder. So of course, when we are defining by the tool tip, I need to calculate or also make sure that the part is completely, because there is an this conic shape at the tip of the tool. So maybe it is easier to consider the shoulder for me. And I know that my whole total height of my part, or let's say my raw stock, was 155. So I would just put 155 and then makes just check it out again and verify it. Let's play that one. So now we can see that there is a complete penetration of the whole part. So now the hole is completely fine. So I will cancel that, but let's test something. What will happen if I put this one, let's say 100, so less than what I need actually. If I try to verify this one, I will generate the tool. You could already see that the line appears in the middle of the part, so it's not enough, and it's verified. So it doesn't necessarily mean that it is bad. For some reason, I might like to only do this, do some operation, and then continue after that. But this is just to make sure that we are doing what we are intending. But at this stage, I want to have it the whole throughout the whole part. So I will just define 50 based on the tool shoulder, and that's about it. Then again, I have the feed material. So again, repetitive things. I can define the spindle speed based on the RPM. So you know how to calculate these ones. So for example, supposing that I have calculated and it is 700. Again, I'm just putting a random number here so that we can just show the so that I can show the software to you, not necessarily a calculated one, but you can do it for your own assignments. So this is it. Then we can see that what are the other options, for example, here are not basically something that I can work with it. I'm just looking for if there is any Um, so for example, you have the spindle stop at the end, you have the retraction to smart, so you can define some manual one, for example. So these are the things that you can a little bit play with it. Starting position automatic is perhaps the best. Depth option, for example, you can say that you have the endpoint or something like that. So anyway, there are different options to do that one, and you can also visualize what is the starting point and what is the end point. So starting point would be here and ending point would be there. And you have also options of defining different departure positions and different approach positions. All right. So this looks to be okay. Oh, you have actually dual time also if you want. So you can define a dual. So dual is the one that at the end of the whole operations, in case you want to have some time that it stands on its positions, and you can define it based on the time or number of revolutions. So you can define time. So I want, for example, that the drill stands at the end of the hole for 1 second. So again, generate, verify, and just in case, let's check that again. Now it looks okay, and all right, and we can see that it appears here. All right, let's take a look to what we have now. If we go to the program order number, order view, we have the program that was 1, 2, 3, 4. We have 3 operations it defines. Each of them is associated with the tool, and then the paths are generated and everything looks fine. The tool numbers are correct. 3 to 4 are used, and you can see that currently it is the time that is going to be used is 2 minutes 37 seconds. So then we can see that the drilling itself took 1 minute and 34 seconds, including 1 second that I was defining for the dual time. And then you can have the other values, feed rate, speed and rate. I put the value on the spindle speed, but I didn't put anything on the feed rate. So these are now random values that are here. And you can see that what are the status of other parts itself. Then we can go to the tools here. Everything looks okay. And then we have also different geometries. And then we can see that on avoidance, we have defined these 3 different steps. And then the methods that we have defined. Of course, by double clicking these ones, we are able to change something if we need to, or we can just simply right click and delete those ones. I can see that this might be again, yeah, it might need it to be re-updated, but now it looks fine. Okay, I'll stop here. Now we have defined the first 3 operations. I will stop here and I will continue next with the next operations. All right, let's go to 2 more operations. We'll bring the PDF up. All right, yes. We're gonna have first the rough outside diameter, followed by the groove outside diameter. We're gonna do these 2, and then I'm gonna pause again, and then we're gonna go through the finishing the outside diameter. All right, so for defining the outside diameter, the first thing that we need to figure out or pay attention is that if there is a risk that we are colliding with the spindle. And that is how that defines that we need to put containment in our geometry vocabulary. The tool that we're going to use, and of course the lathe roughing first, and then we're going to do also a lathe finishing. While doing that, it is also important to pay attention that when we have the grooves, the tool intends to go inside the part. So kind of a reverse mode that is going to be activated here, and we're going to choose an option to solve this issue here so that we have a straight line and we don't have going plunge into the parts that is undesired at this stage. The groove tools, so we can have a different groove tools, but anyway, if it is like a family of the groove tools, like it's the one that you can see on the bottom side. If not, then these are the normal groove tools that it can be used also for cut off the parts. We're going to define the groove tools, and then the geometry is avoidance, and then the rest would be just the easy operation. For the group tools, we need to define the limit of starting and at the end, and I will show you what will happen if not. And then sometimes we also need to pay attention to the colliding of the part itself or not. All right, let's go to do these two, and we're gonna solve the issue of the tool path colliding in a moment. All right, I will just go to the software now, and now we're gonna define the outside diameter rough. So let's say that we're gonna use one of the existing tools, for example. Of course, if not, then you can also just define the tools, but now we'll go and generate the tool. I'm going to have an outside rough turning outside diameter. The program number is correct. Let's say I'm going to use this one, whatever tool is suitable for you. This one needs to be containment. This is very important. And then we're gonna have the roughing, lathe roughing. So I'm going to have only one roughing outside, for example. So this is okay. So perhaps it's fine. If not, I can just call it, for example, 1 or 2. So I click OK, and let's see how does that work. Instead of going to generate and verify, we can already see the cutting region here. So the cutting, it was just shown very briefly. So you can see now the cutting region. So you can already see that it's a start to go plunging to the part that is not desired, then it goes up again and again going to plunge to the part. So these are very inducing a huge forces and heat to the tool, and it should be avoided. And then we can also see it this way, generate the tool and verify the tool again. If I just increase a bit, so here it's fine, here it's fine, but then here it starts to, yeah, here and here they start to have a problem. So we need to avoid these two in a sense. And you can see that it was also a red line showing that there would be some kind of error here. So for this one is actually an easy fix. So the reversal mode here, what we need to do is to put it on omit. And this is rather an easy fix. We can check it out by the cut region here. And is it updated? Now it is, it's got updated by generating the tool. We can see now the cut regions, even though it is fine, but let's see. Maybe we should just create the verify, and maybe that would be faster way to check that. I can even check these off, and without even playing, I can see that it looks fine. I go to the fastest mode, and or maybe it was a bit too fast. Let's see. So at least the path shows that there wouldn't be any negative penetration to the part itself. So now it looks fine here. So we're gonna do the pathing of the rough, and you can see that we have this much millimeter left for the finishing. You can see already the software considered those ones, but we should be able to also define the values also. All right, so the problem is solved here. Then of course, again, we can have a different strategy of the cut. We can have, again, different maximum depth or something like that. So these are the values that you need to change based on your decision, or for the sake of assignment, you could see if there are any limitations defined here. Again, similar to same things, you have the cutting, defining the spindle speed, for example. So again, I will define something here, but these are the things that you need to calculate. Also the feed rate you need to calculate based on the catalog that you have. Then we have also non-cutting movement that actually now we don't need to go through it here because there wasn't any issue. Again, generate and verify. So I don't play it now. I just do it this way so that it just go at the end and it looks okay. All right, that was it. And now what we need to do is that to quickly check that this roughing outside diameter is there, and we are good to go. We're gonna go to the grooving, and then after that, I'm going to pause again and go into the next operation, and you can reply to your cases as well. So for the operation of grooving, we need to first create the tool, maybe. We'll first create the tool. It's the outside groove. It's actually this one, outside groove L. I'm going to define it in, let's say, station 5. If I want to put any size, I can, since I might use actually two different groove tools or something like that, but now let's use only one. Let's say that our insert is 4 millimeter width, because I think this one was only 5 millimeter, for example, or I could do it even smaller, but of course, this is really depending on what is available, what is the material. You should be able to define those. And of course, again, similarly and repeatingly, holder and then what are these values and so on. But I just leave it for now to save some time. Now we have appeared it here. And now we are ready to define the operations. And for the operations, we have here groove OD. So groove outside diameter. Then we have the choosing on avoidance. Then here we're gonna use the groove on the same program, and here groove lathe groove. So it doesn't matter if it is internal or external or inside or outside the part. So groove OD. Here, it's better to call it because we're gonna have apparently 1, 2, 3, 4 grooves. I might not do all of them, but now for the sake of this presentation, now I will do, for example, the first one. So this is the one. I click OK. Let's see what already generates for me. Now I can see that there are already an error, and I can see that actually the groove goes all over the part. So this is not accepted, and it goes actually even inside. So this is totally wrong and problematic. So how to solve the problem? It's actually, again, easy. What we need to do is to check the cutting region. You can see that now this is the cutting region, and actually at the end it kind of does the cut off the parts and then go here. So this is not what I want. So I just go to edit, and I just need to now to define two axial trim plane on either side, both sides of the groove. So for example, supposing that this is what the groove that I want like to make the groove. I'm now defining an axial trim plane 1, axial trim plane 1 on the points. And let's see what will happen if I put first this point, or I might have need to do it the other way around, but let's see now. And then the other point would be this point. The error that you see that it appears, it's saying about the potential collision. So first, now remember that we have put the first point on the left side and the second point on the right side, and we'll see that if we need to change it later on. Let's see what we'll have here. I might have also made a mistake, but let's check it out. All right, and now verify the tool. Let's put it on 9. We have the tool doing the things. All right. So the cut region seems to be correct, but as you can see now, it does the groove and then it collides. So this is something that we need to solve it. And for that one, we need to go to the non-cutting moves. After going to non-cutting moves, then we can go to the departure tab here. And after that, we have this motion to return point. And for that one, you don't need to memorize anything. You can just come here. This is direct. Safer option, of course, is to do the radial first and then axial. So we do that one, and then we will now generate the toolpath. So yeah, I have no error here. And then oh yeah, so maybe departure mode should be maybe first radial and axial, and then let's see what will happen if I put this one. Return point cannot be same as start point. All right, let's define another point, for example, somewhere here. Let's figure it out and see that if there would be an error again or not. I will verify again, and then I will play it a bit slower. Now I can see that there wouldn't be any problem, except that perhaps it would have been ideal to even approach it differently, but I think it's fine. But if not, then I can again try here. Approach would be, for example, maybe radial and then axial, and then again it needs a point. I will just define it here. So let's see how does that work. Again, I will generate, and then now I will verify now, and then oh yeah, now it did this kind of a movement, but it's all right. Now it wouldn't create a problem. Now this is okay. And now we have the groove one added here and the one added here. So I would now pause it before we go to the finishing outside diameter, finishing the external, so outside of this shaft, and which is that one is a little bit challenging. So I will now pause it. You can apply it to your model, and then I will record another video.